Alright, welcome back, students. In this video I'm going to do the study guide for Module 8. Just going to go right into it here. Number 1, fill in the blanks using the available answer choices. Use the figure to complete the statement. Alright, so the transformation from JK, rectangle JKLM, so JKLM, we're going from this, so this is our old. This pen, okay, that one done right. This is our old from, and then we're going to NOPQ with 2, and this is our new. Is a blank with a scale factor of blank, so it's an enlargement or a reduction. So we're going from here to here. Are we getting bigger or smaller? Well, we're getting bigger, so it's an enlargement, but let's go ahead and prove that first. Remembering from from the module that scale factor is greater than 1, it's an enlargement. So I'm just going to put this beside that. Reduction is going to be between 0 and 1. So greater than 0, less than 1. But so, and then to figure our ratio, it's going to be our scale factor, new over old, so we'll take our corresponding sides, JK and NO. So new is 24 and our old was 3. We divide those, 24 divided by 3 is 8, so that's our choice here. Our scale factor is 8, that's greater than 1, so, and we can tell it's bigger, but now we mathematically proved it's an enlargement. Just scooch the page here. Okay, number 2. Excuse me. Triangle ABC has vertices and gives us the coordinates there. It says a dilation with its center at 0, 0. So from the origin, maps triangle ABC onto triangle A prime, B prime, C prime with a scale factor of 2. So we'll just circle that. So they're asking us, excuse me, about this dilation, scale factor of 2. So here's our coordinates. They want to know what the A prime, B prime, and C prime is. So for this, our coordinate rules is x comma y becomes 2x comma 2y. So start at 0 for A, the x coordinate is 0. 0 times anything is 0, so 0 stays the same. 2 times 2 is 4. So we have 0, 4 for A prime. All right, B was at 4, 6. 4 times 2 is 8. 1 second. All right, and 6 times 2, the y coordinate, 6 times 2 is 12. So we have 8, 12. We'll scratch that one out. All right, and then C prime. So C, we were at 8, 4. So our x, 8 times 2 is 16. And then our y, 4 times 2 is 8. And then 16, 8. So there's our 3 new coordinates based on our scale factor of 2 dilation. Give me 1 second. Let me refocus. Feels like that. Okay, yeah, that in there is a little. There we go. All right, number 3. All right, a dilation centered at the origin maps the point 3, 6 onto point 5 fourths, 5 halves. What is the scale factor of the dilation? So here's our old, here's our new. No, wait a minute, let's see, maps this point, yeah, onto that point. Except here we're gonna, hold on 1 second. Okay, sorry about that. Alright, so new over old, so I believe this is contrary to what we talked about in class, so just wanted to verify that. So, our new 5 fourths over 3, and when we multiply that out, we get 5 twelfths, and then over here, 5 halves over 6. multiply that out, we also get 5/2. Let me just show you down here below. So 5/4, and basically, because this is on the bottom, it's like 1/3. So 5/4 times 1/3. 5 times 1 is 5. 4 times 3 is 12. Same thing over here, so it's 5/2, 1/6. That's basically how that works out. 5 times 1 is 5, 6 times 2 is 12. So just wanted to show you guys that. All right, flipping over, page 2. Number 4 at the top of the page. Oops. All right, so a dilation, excuse me, maps rectangle RSTU. So this maps this onto this. So this is old, this is new. New over old. So new is 2, old is 8. And that reduces down to 1/4. We also have 1.5/6, which also reduces down to 1/4. So our answer here is 1/4. And notice, so similarity ratio, that's the same thing as the dilation. Or actually, it was worded differently. I meant to bring that up to you guys. It'll come up in a minute. Give me just a second. We shall keep going. Scooch down the page, number 5. Keeps moving on me. Let me scooch. All right, number 5. Bottom of page 2. Quadrilateral. ZXYW is similar to quadrilateral ABCD. Place the vertices of quadrilateral ZXYW in order based on their angle measures from least to greatest. Okay, so if ZXYW is similar to ABCD, we're just going to say, so ZX goes over here with B, Y goes with C, W goes with D. So now we can look at it and say, okay, 75 is the smallest. So let's see, 1 would be X. And this, I'm not sure, I think we had a typo there. So the smallest is X, next is Z, the third is Y, and the biggest was W. Okay. Flipping over to page 3. All right, page 3, number 6. A corporate logo is a rhombus, right here, centered on a regular hexagon. The logo will be dilated 450% to be printed on a banner. What is the perimeter of the hexagon on the banner? All right, so we're talking about the hexagon and its perimeter on the banner. This is just the logo, and they're going to dilate it. So 450% we know is the same as 4.5. So we're going to say these sides are all congruent. So we have 6 sides times 4 centimeters, because they're all 4 centimeters, means the perimeter of the logo is 24. So now to get the banner, it's going to be that perimeter times the dilation, 4.5, 450%. Get the calculator. So 24 times 4.5 is 108. So the perimeter of the banner is going to be 108 centimeters. Okay, let's scooch down to the bottom. Get this whole problem in here so you can see it. All right. Okay, I think we can see everything on the screen for this problem, or word bank. All right, so number 7. Fill in the blanks using the available answer choices. In the figure, triangle ABC, mapped onto FDE by a series of dilations and rigid motion. Complete the statement about the triangles. All right, so let's just make some notes of things before we even look at the proof down here. So we have 2 right triangles. So this D, which would go with B, is 36 degrees, and then A, which would go with F, and it says it can be mapped onto it, so we know that A and F go together, so they're both 54, and B and D go together, and they're 36, and if you add, you'll see 54 and 36 equal 90, and that 90 plus 90 is our 180 for our triangle. So just making a few notes here. So it says because dilation and rigid motions preserve blank, so our choices are side length or angle measure. Well, we just talked about the angles. So they preserve angle measure. Excuse me. The blank can be used to prove that triangle ABC is similar to triangle FDE. Alright, so our choices here are angle angle, side side side, or side angle side. So we didn't talk about the sides at all. So this would be out, and this would be out, and we have angles, so these are right triangles. It would be an angle angle similarity. If we were talking about congruence, it would be angle angle congruence, but we're still in similarity. Okay, let's flip over to page 4. Number 8 at the top. Alright, Jeremy stands so that his shadow and the shadow cast by a flagpole end at the same point. That's going to be this point. If Jeremy is exactly 74 inches tall, what is the height of the flagpole in feet? So we end up with two similar triangles here. They both have the same endpoint. And we're going to use, it's going to be Jeremy to the flagpole, or the flagpole to Jeremy. And then wherever we start, we'll put on the top of the other side, but it'll be Jeremy's shadow to the entire shadow. So in just a second here, we need to convert. They gave us his height in inches, and everything else here is in feet. So we're going to just convert. So 74 inches divided by 12 inches is 6.166667. So it'll be 6. We're just going to say 6.2. I'm just going to round it. So 6.2 feet. And the flagpole we don't know, so we're going to call it X. All right, so we're going to say flagpole. So the flagpole's height to Jeremy's height, 6.2, is to the whole. So the flagpole, its shadow is the entire way. So 16 plus 8, or 24, to Jeremy's shadow, which is 8. And now we cross multiply. 8 times X is 8X. 24 times 6.2 is 148.8. We're going to divide both sides by 8. We're going to get that X is 18.6. So that flagpole is 18.6 feet tall. Okay, let's scooch down to the bottom of the page, number 9. I have a small proof here. I think we can't quite. Let's just see if I can zoom out just a little. There we go. Wanted to get the whole word bank in here. I know we do have a problem on this, that we're missing the word bank, but we'll work through that together. So match the reasons up to the statement given for the proof. They give us that HGI and HFJ are congruent, as we've got marked now. And statement 1 says the same thing, HGI and HFJ. That was given. I'm just going to do it here instead of here. Given. So I'm just going to do that. It doesn't really matter. It prints out like that because it's a drag and drop in McGraw-Hill. All right, number 2 says that GHI, so GHI and FHJ are congruent. Well, those are the same angle. I told you guys before, so the middle is our vertice. They're both H, so it's the same angle, and that is reflexive. Alright, and number 3, they're asking how the triangles are similar, and we have an angle and an angle. So that's angle, angle similarity, or AA. And of course, those were choices, so that helps. Okay, let's flip over page 5. I'm going to have to scooch again. All right, number 10. So let's zoom back like we were. There we go. All right, is triangle ABC similar to triangle DEF? Explain your reasoning. Okay, so A, B, C, D, E, F. So this side to this side, so it'd be 3.6 over 6. We're going to see if these ratios are the same. And then BC is 3, EF is 5, and then AC is 4, and DF was 7. So 3 divided by 5 is 0.6. 3.6 divided by 6 is also 0.6. So we've got 2. Let's see if we have a third side. And 4 divided by 7, well, that is 0.57. So I'm going to say no. And it's because the corresponding sides are not proportional. What does this say? BC, yeah, it has, we don't want them to be equal. We need them to be in proportion, and they're not. So the answer is B. Okay, scooching. Number 11. All right, which reason proves that triangle FHJ is similar to GIJ? Okay, so let's check our sides. So GJ and FJ. So we have 2.55, which is 1 to 2. And then this other side, 3.5 to 7, which is also 1 to 2. We don't know the third side, but hopefully you guys have already remembered. You see this guy right here, so FJH and GJI are vertical angles right here, which are, they're always congruent. So we have a side, an angle, and a side. So we have here. Okay. Scooching down, number 12. What is the length of IJ? So IJ is right here. So we can do our corresponding sides. We're going to go, or we'll just go 1 to 2. And then we have X over 2.5. Cross multiply, we have 2x. 2 times x is 2x. 1 times 2.5 is 2.5. Divide both sides by 2, and x equals 1.25, which hopefully you guys saw here. So our ratio was 1 to 2. Half of 2.5 would be 1.5, which is what we got. Okay, sorry. For any of you guys listening, and extra credit if you're listening enough and you catch this, but yes, Sadie just left. She was watching, she wanted to watch me do the video. Of course, she got bored with it, just like you guys. That's why I'm saying if you're even listening at this point, and not fast, just getting the notes. Anyway, if you mentioned to me that you heard Sadie in the video, I'll give you extra credit. So, number 13. Page 6, I went ahead and flipped it. That's why it's, as I unpaused, it was changed. I mean, the page was already changed. Anyway, we don't have a word bank for this, so, but hopefully I can walk you guys through it enough that I mean, I know I've said it before. When I was in school, we didn't have as many word banks as you guys have. We had to know a little bit more, and that's kind of why I try to push things for you. And if I can get you guys to be able to work some of these proofs without the word bank, then with a word bank should be no problem, because you really should get good enough to be able to eliminate just based on the circumstances. Anyway, so number 13, fill in the statements and reasons. Use the diagram. Are given. So this was statement 1 and reason 1, but so point B is the midpoint of AC. So B is the midpoint of AC. So before I even look any further, I told you guys, let's look at the figure, look at what we're being told. So if B is the midpoint of AC, that makes AB and BC congruent. Okay, and it says D is the midpoint of CE. So over here, CD and DE are going to be congruent. I know this, and before it even talks about it, and that this, if you guys will follow me, it'll help. So we've marked those things; those were given. Statement 2: AB is equal to BC, and CD is equal to DE. And why? It's the definition of a midpoint. I knew that. If this is the midpoint, these two have to be congruent. If this is the midpoint, these two have to be congruent because it's a midpoint. All right, statement 3. AB plus BC equals AC, and CD plus DE equals CE. We're talking about a line segment plus a line segment, or we're adding line segments. Segment addition, adding line segments. All right, number 4. So now we've got to actually put something in here. We don't have a word bank. Oh, it's going to be fine. So AB plus AB equals AC. Okay, well that's true, because if AB and BC equal AC, then two of these would equal the same thing. But what would be our reasoning? Well, actually, between here and here, we substituted BC for AB, and over here I bet we did the same thing. CD plus DE equals CE. CD plus CD, so we substituted. So even without a word bank, just look at our letters and stuff. You don't have to understand everything. And I try to get you guys, if we can get enough of it, we can pass this EOC. All right, so now 2AB equals AC. Well, AB plus AB is 2AB. So that's just multiplication. CD, 2CD. That's multiplication. All right, then 2 equals AC over AB. Well, if we went up here and we divided both sides by AB, these cancel. CD, these cancel. Then you have 2 equals CE over CD, and 2 equals AC over AB. So all we did was divide. Fair enough. All right, so down here, AC over AB equals CD over CE over CD. So this guy equals this guy. Well, if 2 equals this guy and 2 equals that guy, then this guy has to equal that guy. And that's transitive. All right, next one, we don't have the statement, no word bank, but number 8 says reflexive. Okay, so let's just look up here at what we've got. So we know these sides are congruent, and if we look, so we have a triangle here that has a vertice of C, and we have the big triangle that has the vertice of C. So angle C, or angle BCD, is congruent to angle ACE. And why? It's reflexive, and that's because that's the same angle. It's for both triangles, but it's one angle. All right, so lastly, number 9. How are the triangles congruent? So we have a side for both of these. This side and this side are congruent to one another. 2 different triangles. And then we have an angle. The angle goes with both triangles. And then over here we have a side and a side. So we have a SAS, or side angle side. Let's see, we didn't need a word bank, because I guarantee you in the test, if you type in SAS, you don't even, it doesn't have to be, if you don't put similarity versus congruence, if you just put SAS, I'm pretty sure we're going to get the right answer, or we're going to be counted correct, excuse me. All right, 14, bottom of page 6. Find the value of x. So x is up here. Go back to red. All right, so we're going to put our sides. So this side would be corresponding to this side. So it's going to be x over 1.2, and then the other side, because this is a triangle and this is a triangle, so it's 6 over 0.5. so 1.5 times x is 1.5x, and then 6 times 1.2 is 7.2. And we divide, give me 1 second, just checking my math. 2, yep, and then 7.2 divided by 1.5, yeah. Divide both sides by 1.5, x equals 4.8. And that would be this guy right here. Alright, let's flip over to page 7. Okay, 15. Given that DE, EF, and DF are mid-segments, what's the value of x? So, the way this sets this up is these triangles all have corresponding sides. So, these two are corresponding, so 42 degrees here, 42 degrees here. This one's 86, so up here is 86. And then whatever this is, that's x, x would go with this. X goes here, x goes here, x goes here. So to find x, we know the triangle complete total has 180, so we subtract 86, and then we also subtract 42. Notice here, so x is here, here, and here. 42 here, here, and here. 86 here, here, and here. All these corresponding sides. So I just want to show you guys over here, x is 180 minus 42 minus 86. 42 minus 86. 42 minus 86. You know. So, take our trusty calculator. Oops. Sorry. 180 minus 86 minus 42 equals 52. Okay, scooching down the page here, number 16. If NO bisects angle MNO, right here, what is the measure of MP? Okay, so MP, we're going to call it X. So we end up with our corresponding sides are going to be, we're going to do 18. Let's see, we'll do, yeah. Hang on, let me look at this a second. We do 18 over 12, and so it's 12x times, let's see. Just want to look at, yeah, that's right. Yeah, it works out both ways. So, we do 18 over 12. If we started over here, then we start over there for the top here, and it's x over 8. We cross multiply. 12 times x is 12x. 18 times 8 is 144. Divide both sides by 12. X is going to equal 12. So MP equals 12. All right, flip it over, page 8. Last page, last two problems here. So, number 17. Just put in our little here, we got here. This good habit to do this first, and I'm very tempted to start giving you guys paper tests so you can do that. I may actually do that again. Anyway, so which equation can be used to find the value of x? So we would have, let's say we start over here. Well, let's see. Actually, just everything starts with x, so let's start with x. X over here would go over 5. So if we started over here, at this one, we have to start with this one. So we got 2 over 3. So we're looking for x over 5 equals 2 over 3, which is this guy. And that's our answer, because I just wanted the equation. All right, easy enough. Last one, number 18. In the figure, triangle ABC is similar to triangle DEF. If AP and DQ are altitudes, AP is 8 and DQ is 10, and DE, that's this guy, is 14. What is AB? It's going to be X for now. So, similar triangles. We're going to go, we'll start with X, so we'll go X over 14. I started with X, so I'm going to go 8 over 10 with the other side. Cross multiply. 10x, 10x. 18 times 4, give me just a second. 18 times 4 is 72. Divide both sides by 10. X is going to equal 7.2, or AB is going to equal 7.2. Well, that's it. That's it for this video. If you have any questions, let me know in class. Until next time, you have a good night.